Hello everyone, I hope you're doing well. So today I'm going to be doing a video tutorial on the latest script file that I posted, the week 5, well really it should say week 6, additional commands. So this is actually part of a series of tutorials that we're going to have on how to format data sets. And how you can clean up your data set, how you can change what your data set look like. You can create new variables, you can create new data sets and things like that. So first thing I'm going to talk about is conditional subsetting, meaning you are creating a subset of your data set based on a condition. So now here, the first condition that I'm going to consider is high smoker countries versus low smoker countries. And in order to figure out where the cutoff point is between high and low smoking countries, I want to figure out what the median value is. So again, I'm using my SIGS mortality data set. And I want to break my data set into two equal halves based on how much cigarettes they smoke. Are they smoking less cigarettes or are they smoking a lot of cigarettes? So in order to find out the middle, because I want to break it up into two equal halves, that's why I first want to look up the median of the cigarettes variable in my cigarettes and mortality data set. So let me run this command here. And so this is the median value. So this is the median cigarette consumption value in my data set, 485. But of course, I actually don't have 485, an observation that has a value of 485. Again, because remember, I have even number of observations. So I actually have two middle values. And this is simply the average of those two middle values. So let me go back to this data set. So 485 is actually the average value of Australia's cigarette consumption and Holland's cigarette consumption. So it's the mean of 480.15 and 490.29. So that's the median. So that's how I get the median value. So that means that I'm going to be breaking up, when I break up my data set into two equal halves, the first half ends with Australia, because that's just above the median, just below the median. And then the second half starts with Holland, because that is just above the median. So my low smoking countries are all the countries that have a cigarette consumption value that is less than 485, ending with Australia. And my high smoking countries are all the countries in this data set that have a cigarette consumption value that is higher than 485. And it is starting with Holland, which has 490. Okay, let me go back to the code. So now I figured out my cutoff value, 485. So that's the median values. Again, I'm just writing 485 rather than 485.22 because, as I said, I don't really actually have an observation with a value of 485 or 485.22. And, so this is just in between. This is a value in between 480 and 490 as I showed you guys in the data set. So now what I want to do first is create a dummy variable called high smokers. So a dummy variable is the simplest variable. So we've talked about dummy variables. It has a value of either 1 or 0. If you get a value of 1, if you share that characteristic, so in this case, if you share that characteristic of being a high smoker, or you get his value of 0 if you do not share the characteristic of being a high smoker. So you can actually organize your dummy variable to be just 1 or 0, or you can simply do true or false. So high smokers will get a value of true. So this variable will get a value of true if the observation is a high smoker, meaning it has a cigarette consumption value that is above the median. And then the high smoker variable will get a value of false if it is not a high smoking country. Meaning the cigarette consumption value for that country is less than the median value. So now this is how I'm defining it. So the default is that high smokers will be defined. We're going to be defining the true statement, what qualifies as true here. So high smokers will get a value of true if the cigarette consumption variable in my SIGS mortality data set has a value greater than that median. So I'm going to run this command, okay? And then let's go back into this data set. So now you'll see that a new variable has appeared in this data set. It's called high smokers, and that's precisely what I call that variable. Right? So whatever I typed in here is the name that you see here. And every observation that had a value greater than the median value has now true for high smoker. So 500, true. 1,000, true. 1,100, true. And by default, you don't have to actually go, let me go back to our command. You don't have to do anything else. So this statement defines which observations will get the value true, and every other observation by default will get false. I didn't even have to do anything else. By default, every observation that did not fulfill what I highlighted in my command automatically got a value false for the high smokers variable. So now you'll see that I have a true or a false value for this dummy variable for every single observation, depending on whether their cigarette consumption value is greater than or less than the median value. Okay, so now I have created this dummy variable, and I can actually use that dummy variable to only consider certain parts of my data set. But before I do that, I'm going to first talk about how to get the mean for only the high smoker countries and only the low smoker countries. But before I do that, let's remember what the mean commands looks like. So here's the mean command. So I want the mean of the mortality data set in my SIGS mortality data set, right? So again, I'm not subsetting anything. I'm doing this for the entire data set now. So what is the mean mortality rate value in my data set? 221. So now I want to find the mean of a mortality. So the mean mortality rate value in my cigarettes and mortality data set, but I wanted only for the high smoking countries. Meaning I only want the mortality rate mean for the observations where the dummy high smokers has a value of true. So that's what this command means. I want the mean value for the mortality rate variable in my SIGS and mortality data set, but I only want the mean mortality value for those observations where the high smoker's dummy variable has a value of true in my SIGS and mortality data set. So I only want the average mortality rate for high smoking countries. So let me click run. 310. So it makes sense that high smoking countries, the average mortality rate for high smoking countries is higher than the average mortality rate for all countries, which also include the low smoking countries. So now I'm going to do the same thing for only the low smoking countries. I want the mean mortality rate value in my cigarettes and mortality rate, but I only want to get the mean value for the low smoking countries in my data set, meaning high smokers dummy has a value of false. in the cigarettes and mortality data set. So now let's find the mean mortality rate for low smoking countries in this data set. So let's click run. And then we find that the mean is 131. Again, that makes sense, right? So this is the mean mortality rate for only the low smoking countries in my data set. So it makes sense that it will be lower than the overall mean for the entire data set. And it will be much lower than the high smoking country mortality rate average value. So I've done this for mean, but of course I could have also, so here I chose to create a dummy variable called high smokers. But of course I could have also done the same thing without even creating a dummy variable. So now I could have asked for, so remember how I defined the high smoking countries. Cigarette consumption has a value that is greater than the median, greater than 485. So instead of writing that the high smoker variable dummy in my data set, in my SIGS and mortality data set has a value of true, I could have just as easily written cigarette consumption variable in my SIGS and mortality data set has a value that is greater than the median, right? So that's essentially the same thing. So you can do this exact same thing without creating a dummy variable and simply by specifying that I want only the high smoker countries, meaning the cigarette consumption is greater than 485. So I only want those observations where cigarette consumption value is greater than 485. And this was exactly the same thing here as well. So again, the mean mortality rate in my SIGS and mortality data set, where in that same data set, the cigarette consumption value is greater than 485, meaning they are high smoking countries. And of course, I get exactly the same value, right? Because I did exactly the same thing, just a different way of doing exactly the same thing. Okay, and then of course I can do the same thing for low smoking countries. In this case, the low smoking countries are the ones that have a cigarette consumption that is lower than the median, meaning less than 485. So again, it doesn't matter. I could have written 485.22 here. It doesn't make any difference because, as I said, I don't have a value in my data set that equals exactly 485. I also don't have a value in my data set that equals exactly 485.22. I have a value that's 480 and another value that's 490. So it really doesn't matter whether I round or not to the nearest integer here. Okay, so now let's do the same thing. The mean mortality rate for low smoking countries. Same thing, right? So 131, that's exactly what I got with the previous set of commands. But of course, if I wanted to, I could just simply break up my data set into two equal halves. So instead of having one larger data set, I can create two smaller data sets. One data set that is only containing the observations that are high smokers, and another data set that includes only the low smoking countries. So here, this is on the left-hand side of the arrow. This is what I'm calling my smaller data set, the high smoking data set, the data set that includes only the high smoking countries. And then the command is subset, meaning I am subsetting my original data set, SIGS mortality data set. And here's how I define that division. So the new smaller data set called high smokers is going to include only the subset of the original SIGS and mortality data set where the observations have a cigarette consumption value that is greater than 485. So high smokers will only include those top half of the original data set where cigarette consumption values are greater than 485. So I'm going to run that. And when you run that, you'll see that a new a new data set has been created. So actually, let me go to list here. Okay, a new data set has been created. The original SIGS mortality data set had 30 observations. And now high smokers contains only half of that data set, the half that has only the high smoking country. So let's take a look at what that looks like. All right, so again, this is the data set. And of course, you'll notice that the dummy variable that we had already created is true for every single observation in this data set. So now I'll do it again. This time I'll create a low smokers data set. So I only want that half of my original data set where the cigarette consumption value was less than the median, 485. So let's do it. And then you'll see that here you have another data set that has appeared. 15 observations, the remaining half of our original data set. So let's see what that looks like. And then this is it, 15 observations, and they're all low smoking. And you'll see that the dummy variable high smoker has a value of false for the entire data set because they're all low smoking countries. Okay, so now I can do it again. If I want to get the mean value for the mean mortality rate value for only high smoking countries, then I could just do it so I can just do the mean value of the mortality rate variable in only the high smokers data set. And then, of course, I get exactly the same thing, 310. Right? So again, I'm not doing the mean mortality for the entire data set. I'm asking Rstudio to calculate the mean value of the mortality rate in only the high smokers data set where you have only the high smoker observations. And I can do the same thing for the low smokers data set, mortality rate, the mean mortality rate for all of my observations on my low smokers data set. Again, it's exactly the same thing, 131, and that's what I had gotten earlier with the other set of commands. So now this is what you had to do for the bonus question on homework 1, right? So you first had to create a dummy, and here I'm just calling it dummy. And then the dummy variable was based on the so let's open the EU data set. I've already created a dummy variable, so ignore this last column here. So the dummy variable is based off of the value observed for the agricultural land variable. So if this value here is greater than 50, then it is considered to be agricultural. And if it is less than 50, then it is considered to be non-agricultural. So let's do that. So I want to create a dummy variable called dummy in my EU data set. And it is going to be based off of the agricultural land. So again, the default is true. So this is how I defined a true. Agricultural land variable must have a value that is greater than 50 in order for it to be true. So let's create this. And then let me go back to my EU data set. So here you see that every observation that had a value greater than 50 has a value of true. So that's how I define true, and everything else gets a value of false. So as I said in Rstudio, true and false is the default. But of course, I can change it to, suppose I want to do 1 and 0, right? So I can easily do that. All right, so I'm just going to this is the command that I'm using, that I want to change all of the trues to 1, and I want to change all of the falses to 0. And you see that that's exactly what happened here. Right, all of the trues are now a value of 1. So that's 1 if you are an agricultural country, and 0 if you are not an agricultural country. But I'm going to keep it as agricultural. So instead of true and false, instead of 1 and 0, I want agricultural versus non-agricultural. So that's how I want to define the values of that dummy variable. So that's what I'm going to do. So change all of the trues to agricultural, change all of the falses to non-agricultural. And you actually don't even need the which here. I put it there because it helps me to organize my commands, especially. All right, so as I said, I'm going to call these instead of true or false or 1 or 0. I want these to be called agricultural versus non-agricultural. So here I'm just changing true to agricultural and false to non-agricultural. And you see that is precisely what has happened. So here, this is actually doing it based on, there we go. I had this organized based on the values for dummies. So now, if you click on the variable name, you'll see that, if I click on the country name, you'll see all of these observations that are ordered according to the country name, or you can order them based on agricultural value from smallest to largest or from largest to smallest. And then that's what I had here originally organized in terms of non-agricultural and an agricultural. But of course, I want to keep the original data set with the same observation numbers. Dummy. So again, you see that all values of agricultural land that are less than 50 are now getting the label non-agricultural. And all variable observations that have a value greater than 50 now get the title or value agricultural. So now that's what I want, because I feel like it's more meaningful in the box plot, in the double box plot, to organize the box plots based on agricultural and non-agricultural rather than true and false, right? When you're looking at the box plot, if you just see true or false at the bottom of a box plot, it's not going to make that much sense. I want to organize my double box plots based on agricultural versus non-agricultural. So again, this is how you can change the values of your variables. All right, so this is on the right-hand side of the arrow is what the new value is. And here you have the original value. All right, so now that I've created my dummy variable and now that I've organized the values of that dummy variable, now let's do the double box plot. So again, just make sure your library ggplot is turned on. And then let's do the double box plot. Okay, so here, because, again, just like always, I'm doing a vertical box plot. So it is GDP growth. That is going to be the Y variable. And then I'm going to be organizing. So now I'm adding an X variable. So here the X variable is dummy. That dummy variable that I created. And I'm going to have two box plots side by side. And it's two because I have two values for my dummy variable. So suppose I have 3 values or 4 values, then I would see 3 or 4 box plots side by side. But because I only have 2 values to my dummy variable, I'm only going to get 2 box plots that are side by side, and they will be organized horizontally, meaning one to the left, one to the right. So that's why dummy is the X variable. And then the rest are the same. You can actually, label your X and Y axes, label your entire plot. So now let's run this command. And this is what you get. Right, so at the bottom, you have the dummy variable values, the 2 dummy variable values that I defined as agricultural and non-agricultural. So that's precisely what you're seeing here. Right, again, if I had just written down true or false, it would not have been that informative. So that's why I want to change the values here. And then you have, this is the box plot for only the box plot for GDP growth variable for only the agricultural countries. And then you see two outliers. And this is the box plot for GDP growth for only the non-agricultural countries. All right, so that is it for this tutorial. And today we're going to finish the bivariate analysis and also learn every single code you need to learn for the second homework assignment. All right, so I'll see you guys this evening for our class. Bye.